Alrighty, so welcome back to another session of our plant identification series. Up until this point, we've kind of just been assuming that leaves are this flat, two-dimensional structure like a sheet of paper. But of course there is a lot more to it, because if we do view a leaf from a side angle, you can see that it's not just perfectly flat. And for some species, this can be rather diagnostic of what species you're looking at. Before we get into that though, let's just get two pieces of terminology out of the way. We need to be able to describe the upper and lower surface of a leaf with the correct terminology. So the upper surface is the adaxial surface, and the lower surface is the abaxial surface with a B. So I kind of remember this as B standing for bottom. So bottom of the leaf, abaxial, top of the leaf, adaxial. So, three-dimensionality of a leaf. The first thing that we can describe is the thickness of the leaf. And I've got an example here, Pseudopanax lesonii, which has very thick lamina. And it kind of makes the lamina feel rather leathery. And a leathery lamina is what we call coriaceous. Additionally though, we can also describe what the lamina is doing in three-dimensional space, because some species the leaves are curving or folding, for example. So I've got an example here of Pahudikawa Metrosideros excelsa, and if you look very closely at the edges or the margin of this leaf, you can see that they are curving downwards towards the abaxial underside of the leaf. So you can see the margin curves downwards very slightly, and this is what we call recurved. So it's curving downwards but not a huge amount. If it was more extreme and it was kind of curving all the way around and rolling in on itself, that's what we call revolute. So we've got recurve here, and if it was more extreme, revolute. There is another version of this where it's curving upwards, because that was curving downwards towards the abaxial surface. If the leaf is curving upwards towards the adaxial surface, we've got here mahoi, it's got a very slight curve upwards. That is what we call incurved. So it's kind of curving in, up on itself, incurved there. And if it was more extreme and rolling all the way round, that is what we call involute. So there you go, you've got recurved and revolute for curving towards the abaxial surface, and you've got incurved and involute for curving towards the, or upwards towards the adaxial surface. Alright, we've got one or two other pieces of terminology that I want to introduce you to. One of them is on this red matipo here, the Mersine australis. Can't get closer to that one because there's a huge spiderweb in the way. We'll choose this one over here instead. Let's see if we can find a good example of this. Here we go. If you look very closely at the margin of red matipo from the side, you can see that it's extremely wavy. And a wavy margin is what we call undulating. So it's an undulating margin. And you can see it's just on the margin for this species, but it can sometimes be the entire leaf could be undulating or undulose. So just keep that in mind. And finally, actually I've got two more pieces. If we have a folding leaf rather than a curving leaf, so for example we've got Phormium tenax here, and we're currently actually looking at the abaxial surface here. This leaf is kind of twisted over upside down. So we're looking at the underside of the leaf. It's actually folded down the center, and it's kind of creating almost like the keel of a boat, and that's exactly what we call this. This leaf is keeled. So there's a piece of terminology there, and this final piece of terminology, I don't actually have an example in this bush to show you, because the only species I know of that has this is quite a rare one. I did come across it the other day, and the piece of terminology is bullate, and that essentially means a warty or lumpy or blistered looking lamina. And the species that I came across is Lophomertus bullata. So yes, sometimes the name of a species is chosen based on its descriptive characteristics, because bullata is referring to the bullate leaves of this species. So yeah, that is kind of an introduction to some of the more common three-dimensionalities of a leaf. So we covered coriaceous leaf, or a leathery leaf. We covered a recurved leaf, which is curving downwards towards the abaxial surface. We covered revolute, if it's more extreme and kind of curving in on itself or rolling up. And then the opposite of that towards the adaxial surface is incurved and involute. And then we covered the wavy margins of red matipo. There's one there. And that is undulose or undulating. And also the keeled leaf of the Phormium tenax. And the bullate leaf of Lophomyrtus bullata. So hopefully that gives you a bit of a crash course into the three-dimensionality of leaves. So just keep in mind that leaves are not a flat two-dimensional structure. There is more to it. Hopefully that helps, and I will see you in the next session.